So we're going to start talking about mole concept in this unit, and we're going to start today with understanding the definition of a mole. Now, when you hear the word mole, you might think about skin moles or lovable, furry, live moles, but that is not what we're talking about in chemistry. In chemistry, we're talking about the mole, which is the amount of a substance that contains exactly 6.02 times 10 to the 23rd particles. These particles can be anything: atoms, molecules, green peas, or baseballs. As long as it is 6.02 times 10 to the 23rd of them, it's a mole. Now, what you have to understand is that 6.02 times 10 to the 23 is a very, very large number. It's as if you took the number 602 and then strung 21 zeros out behind it. If I had a mole of marbles, I could bury the earth in marbles 3 miles deep. 6.02 times 10 to the 23rd is called Avogadro's number, and it was named after the scientist who named it, an Amedeo Avogadro, who discovered this number and declared that it was the number of particles that existed in exactly 1 mole of any pure substance when he was studying gases. Now, don't get too confused. Moles are easy. Mole is a counting unit like a dozen. It's a word that represents a specific amount. It's just a very, very large number. So, if I say I have a mole of carbon atoms, then I mean I have 6.02 times 10 to the 23rd carbon atoms. If I have a mole of carbon dioxide molecules, then I have 6.02 times 10 to the 23rd molecules of carbon dioxide. If I wanted to count the total number of atoms of carbon dioxide in 1 mole, well, there's 3 atoms total in 1 molecule of carbon dioxide. So if I multiply Avogadro's number by 3, I would get the total number of atoms in 1 mole of carbon dioxide, which is 1.807 times 10 to the 24th. If I had a mole of eggs, we'd be eating eggs for years. So we can use the triangle of doom in order to rearrange any number or any calculation that involves going between moles and some sort of particle using Avogadro's number. So if I multiply moles by Avogadro's number, I would get the number of particles. If I divided the number of particles by Avogadro's number, I would get the number of moles. So let's look at an example. Let's say I have 3.01 times 10 to the 23rd atoms of silver, and I want to know how many moles that is. Well, we know that 1 mole is 6.02 times 10 to the 23rd atoms. So if I take the number of atoms given and divide it by Avogadro's number, I would find how many moles of silver I had, which this ends up being 0.5 moles. Now, please note, it's written as 0.500. That is because of sig figs. So you may need to go back and review how you do sig figs. In this number up here, in scientific notation, all of the numbers in front of the times 10 are significant. So I have 1, 2, 3 sig figs. In my answer, I start counting at my leftmost non-zero number, and then I will go 1, 2, 3 places out. And there's where I cut off. So let's see you try one. Pause the video and see if you can figure out how many moles of lead are in 1.5 times 10 to the 12 atoms of lead. Let's back that up. So what you should have gotten is if I do 1.50 times 10 to the 12th power and divide it by Avogadro's number, I should get 2.49 times 10 to the negative 12th power moles.
Teachers, please pardon this interruption. Teachers, today were issued a purple.
Sorry about that. Let's pick this up. So here's another example. Let's say that I have 1 mole of silver sulfide, and I want to know how many silver ions would be in 1 mole of silver sulfide? Well, silver sulfide's formula is Ag2S. So there is 2 moles of silver ions and 1 mole of sulfide ions in 1 mole of silver sulfide. So if I want to know how many silver ions I have, I would take my 2 moles of silver ions and multiply it by Avogadro's number to get 1.20 times 10 to the 24th ions of silver. Your turn again. Pause the video and see if you can figure out how many atoms of aluminum would be contained in 3.5 moles of aluminum. So to solve, you would take the 3.5 moles and multiply it by Avogadro's number. And it would give me 2.1 times 10 to the 24th atoms of aluminum once I round to sig figs, which would be 2. So as another side note, remember that when we are doing sig figs in math with chemistry, we never use constants such as Avogadro's number for my sig figs. I always go to my given amount. Why is this important, you may ask? So what we're doing here is we're starting to move away from the micro world that we have been living in terms of amounts of things that we cannot see and work with in the lab, and we're going to move into a world where we're dealing with amounts of chemicals in grams, and we need to know what the connection is. Right? So we have to understand that when chemical reactions occur, we are breaking bonds between atoms and molecules and making new bonds to form new compounds. This happens at the particle level. So by using Avogadro's number, I can translate that to an amount as in a mass that I can use in a lab, because I cannot work with particles in a lab, but I can work with grams. Next time, we will discuss molar mass.